Hello, everyone. Today I'll be sharing my project on card fraud detection of an e-commerce transaction dataset. At any time during this presentation, please drop questions or comments in the Q&A section of the chat. A little about my background. My recent work experience has been in software engineering. Prior to that, I worked in data analysis and finance. I have a BA in economics and management information systems and 2 master's degrees with the latest in research. As part of the presentation, I'll be starting with the business problem, going over data and models, and ending with the recommendations and feature steps. Now I'll go over the business problem. Financial institutions care about accuracy and want to minimize false positives by not incorrectly flagging good users. They also want to minimize false negatives where they fail to flag fraudulent e-commerce transactions. Here are a few facts and figures on card fraud. First, card fraud is on the rise, with global losses from debit and credit card fraud almost doubling between 2014 and 2021. Global losses from card fraud are expected to be $397 billion over the next 10 years. In 2021, the FTC fielded 390,000 reports of credit card fraud, and credit card fraud is the second most common type of identity theft in the US. 87% of US consumers use public Wi-Fi for online shopping, whether at a cafe, airport, or hotel. Almost every consumer is affected. Financial institutions have important decisions to make when it comes to managing risks while keeping consumers happy. In this project, I present recommendations to help financial institutions accurately detect card fraud and minimize cost, customer churn, and losses related to identity theft. Financial institutions care most about accuracy as a metric because it minimizes both false positives and false negatives. We need to stop scammers such as Hush Puppy, who was finally arrested in 2020 after scamming millions from banks through card fraud. Check out the interesting documentary on YouTube. The bottom line, purchases made within the first 137 seconds of sign-up and those from a device used multiple times are more likely to be fraudulent. E-commerce transactions in January following the shopping period also have a higher risk of fraud. Now I'll go over the data. The raw data comes from 2 datasets from Kaggle, fraud data and an IP table. The fraud dataset includes almost 151,000 entries and 11 variables, including sign-up time, purchase value, device ID, user ID, browser, IP address, source, sex, age, and fraud classification. The IP table dataset includes about 139,000 entries and 3 variables, including IP address, upper and lower bounds, and country. I used this dataset to map the IP addresses in the fraud dataset to an origin country. There are a lot of concerns about data privacy and proprietary information when it comes to fraud datasets. As a result, most publicly available datasets have either heavily anonymized features or are synthetic. This limits the ability to get useful, quantifiable insights. Other features would have been nice to have within this fraud dataset. For example, card type. Credit and debit cards have different probabilities of frauds because they have different inherent risks and security features. For example, credit cards use credit verification value codes, while debit cards use PINs. The data was also imbalanced, but I addressed this in my models using SMOTE, synthetic minority oversampling technique. Prior to visualizing and modeling the data, I performed a lot of feature engineering. For example, I mapped IP addresses to countries using the IP table and created several variables related to countries. For transactions with hidden IP addresses, countries was mapped to unknown since many scammers are not traceable. I also engineered and sign up and purchase time to create variables for purchase month, weekday, period of day, and a quick purchase variable indicating whether or not a purchase was made within 137 seconds of signup. I used device ID to create device frequency, the number of times a device was used in the dataset. Now, I'll go over the exploratory data analysis. First, I looked at the likelihood of fraud on the y-axis by purchase month on the x-axis. I found that January, following the holiday shopping rush, has the highest likelihood of fraud. Next, I looked at the likelihood of fraud on the y-axis by whether or not a purchase was made within 137 seconds of signup on the x-axis. In the data, purchases made less than 137 seconds after signup are all fraudulent. I also looked at the likelihood of fraud on the y-axis by the number of purchases made from the same device on the x-axis. I found that fraud is more likely to occur when purchases are made from the same device. Next, I analyzed countries, beginning with the top 12 within the most transactions. IP addresses from the United States are most represented, followed by IP addresses that are not traceable. I delved deeper into the analysis of countries by looking at the likelihood of fraud on the y-axis by country for the top 12 countries within the most transactions on the x-axis. Of the top 12, Canada had the most transactions and the United States has high fraud levels. Hidden IP addresses are unknown and are also in the top 10. I dug even deeper into the country analysis by using a map to explore the number of transactions, amount of fraud, and breakdown of quick purchases by country. The United States has the most transactions overall and fraudulent, with a high proportion of purchases made less than 137 seconds after signup, as evidenced by the pie charts. Now, I'll go over the models. I explored several models to analyze the e-commerce transactions and identify high predictors of fraud. The performance and interpretability of the models is summarized in this table. More details on the models, such as the confusion matrices, the receiver operating characteristic curves, and the precision recall curves, can be found in the appendix section of this presentation. The logistic regression models, both the simple and the one with lasso regression, performed well and are easy to interpret with accuracy scores of 92% and 91.6% respectively. I got straightforward quantifiable insights from the odds ratios. The logistic regression model suggests that purchases made within the first 137 seconds of signup are 110 times more likely to be fraudulent. It also shows that a device used one additional time is 8 times more likely to make a fraudulent purchase. The logistic regression model with lasso regularization suggests that models made within the first 137 seconds of signup are at 39 times more likely to be fraudulent. It also shows that a device used one additional time is 29 times more likely to make a fraudulent purchase. Now I'll go over the recommendations. I recommend that financial institutions adopt a fraud probability scoring model to evaluate e-commerce transactions. This model should heavily weigh quick purchases and device frequency, along with other predictors that are most relevant to each institution, for instance, purchase value. The fraud risk of each transaction could be gauged from the scoring model such that transactions with low probability scores proceed with no interruptions. Transactions with medium probability scores would need to pass two-factor authentication before proceeding, and transactions with high probability scores would need to be approved via call to the financial institution's fraud prevention line. I also recommend that financial institutions staff their customer service and fraud prevention departments higher in the month of January, when fraud is higher following the holiday shopping period. Now I'll go over future steps. Future areas for analysis that could build on the findings from this project include time series analysis to spot trends over time. Given the trends from the card fraud worldwide graph and the figures from the Nielsen report, it is evident that card fraud is on the rise. It would be interesting to see if the trends over time within this project's dataset also show that card fraud is on the rise. I would also like to find publicly available real data sets with mostly transparent data and detect other forms of identity theft, such as government benefits and documents, the first most common form. With that, thanks for listening to my presentation. I hope you found it insightful. If you have any questions, please drop them in the Q&A section of the chat or feel free to reach out to me on LinkedIn. For more information, there are links to this presentation on GitHub, where you can view sources used and more details on the models in the appendix section. Thank you.